In this video, we are going to learn about the popular Java testing framework, JUnit 5. We will start off by learning how to write basic unit tests using JUnit 5 by taking a simple contact manager application as an example, and step by step we will cover all the important features of JUnit 5. By the end of this course, you will have a solid understanding of how to test your Java applications using JUnit 5. So what is JUnit? According to JUnit website, it is a simple open source framework to write and run repeatable tests. JUnit provides a simple API to test our Java applications. The class or method we want to test is usually called as subject_test. So to write a test, we simply create a Java test class and use the JUnit API to make some assumptions towards the behavior of the subject_test. And then JUnit verifies whether these assumptions are correct or not by either passing or failing the tests. Before writing our first test, let's take some time to understand the architecture of JUnit 5. On a high level, JUnit 5 is basically a combination of three different modules. JUnit Platform is the module which provides an API to launch the tests from either the IDEs, build tools, or console. So when you write a unit test using JUnit, your IDE or build tool or console, whatever platform you're using, uses this API inside the JUnit platform module to launch the tests. Next, we have the JUnit Jupyter module, which provides an API to write our JUnit tests and extensions. In this course, we are going to mainly focus on this module because if you want to write unit tests using JUnit 5, this is the module you need. The next module is JUnit Vintage, which provides a test engine implementation to support backward compatibility for tests written with JUnit 3 and JUnit 4. So if you have some tests which are written using JUnit 3 and 4, you can use this module to execute those tests without rewriting them in JUnit 5. And lastly, JUnit Platform module enables some third-party testing frameworks to build their own API to write the tests and reuse the JUnit Platform module to launch these tests. So this is another interesting update which is part of JUnit 5. Now let's go ahead and write our first test using JUnit 5. So to write the unit test, we are going to use a contact manager application I already prepared before. As the name suggests, this application manages the contact information, and this is a very simple application which contains only two Java classes. The first one is a simple Pojo class which contains three fields: first name, last name, and phone number. And the next class is named contact manager. So this is responsible to store the contact information. Here we have a method named addContact where it takes the first name, last name, and phone number as input parameters and then storing the information in memory using a concurrent hash map. We are using a concurrent hash map because it's a thread-safe implementation of the map interface. So as part of adding the contact, we are performing some additional operations like checking whether the contact already exists or not, and validating the contact information based on some business rules. So we have a method to validate each field in the contact class. So if we open the contact class, we have a method which validates the first name. So it is basically checking whether the first name is blank or not. That means it checks whether it's not null and not empty. We are doing the same validation also for the last name and phone number fields. But for the phone number field, we are doing some additional validations, such as we are checking that the phone number should be exactly 10 digits in length and it should contain only digits and it should start with 0. So once all these validations are passed successfully, we are storing them in memory. This is a very simple application but provides enough functionality to cover all the features of JUnit 5. If you want to download the source code, have a look at the link in the description, and you can also have a look at the written version of this tutorial by checking the blog article. I have linked this also in the description section. To follow along the tutorial, I suggest you to download the source code for the starter project from the link in the blog post, where you will start with a clean slate without any tests. And gradually, by the end of this course, you will reach to the state of the completed project. I'm using IntelliJ IDEA as my primary IDE for this course, and the starter project is using Maven as a project management tool. If you are not aware of what is Maven, I have a comprehensive video tutorial called Maven Complete Tutorial in my YouTube channel. Have a look at it. I will also leave the link in the description section. So to start off, first we need to download JUnit 5 into our project. For that, instead of downloading the jar manually and adding it to the project, I'm going to take the help of Maven to automatically download the jar file whenever it's needed. To be able to do that, Maven needs some information so that it can download the jar file automatically. We call these jar files as project dependencies. So these dependencies can be defined inside the pom.xml file, and inside the file I'm going to add a tag called as dependencies, and under that I'm going to provide the dependency information by typing the group ID as org JUnit Jupyter, artifact ID as JUnit Jupyter, and version as 5.7.0. So this is the information Maven needs to download our dependencies. These are also called as artifact coordinates. I'm just giving the bare minimum information about Maven. If you need more details, have a look at the video tutorial again. So once I type these details, we need to ask IntelliJ to force Maven to download these dependencies. We can do that by clicking on the Maven icon on the top right corner. That's all you need to download the JUnit Jupyter dependency to our project. Now let's go inside the source test Java folder. Again, this is the Maven convention folder structure to store the test classes, and inside the Java folder I'm going to create our contact manager test class. So you know what, let me show a shortcut to do this automatically. So from contact manager class, so let me open the contact manager class, and inside this class just make sure you selected the editor section and press the key combination Ctrl+Shift+T. Then you should see a small pop-up window which asks whether to create the test or not. So I'm going to select that option and click on OK, and IntelliJ automatically creates the test class called contact manager test for us. Inside the class I'm going to create a method called as should_create_contact. The JUnit tests are nothing but methods inside the test class. So JUnit identifies a method as a test when we add the test annotation on top of the method. By adding this annotation, JUnit understands this is a test and starts executing it when we run this class. So if I try to run this class with the empty test method, you will see that it executes successfully because we didn't add anything to the method. So now let's go ahead and add some test logic inside the method. So basically we want to test that a contact is created successfully. So for that, first I need to create an object for the contact manager class, and after that I'm going to call the add contact method inside the contact manager, and I'm going to pass in the first name, last name and phone number details as input. So if you go inside the implementation, we are storing the contact information inside the map, and we have a method called as getAllContacts where we are reading all the contacts present inside the map. So to verify whether the contact is created or not, I'm going to call this method and make sure that the contact information exists inside the list or not. So back to the test class, I'm going to call the getAllContacts method, and as a first step I want to verify that the list is not empty. So this process of verifying our expected output with the actual output is called as assertions. So and JUnit provides an assertion class, and inside that class I'm going to make use of the assertFalse method. So this method will take a boolean parameter as input, and if the boolean is not false, it will throw an exception and will fail the test. So as we expect this list from getAllContacts method should not be empty, I use the assertFalse method. Next I'm going to make sure that there is exactly one element inside this list. I can perform this assertion by using the assertEquals method from the assertions class. This method takes the expected value as the first parameter and the actual value as the next parameter. So I'm going to call the size method of the list written by the getAllContacts method. So now it's time to run the tests. I'm going to click on the green button to the left side of the class declaration and click on run test. And you can see that the test is executed successfully. So we saw how to test a happy path scenario. We added a contact and the contact information is saved to the application. Now let's go ahead and test a negative scenario where the contact creation is failing. So we can test this case by providing some invalid input to the add contact method. If we open the validate contact method inside the contact manager class, we are validating the first name, last name and phone number fields. So now let's go ahead and add a test where we are providing invalid values to all these fields. So I'm going to open the contact manager test class, and I'm going to create 3 methods inside the class to test the case of invalid input of first name, last name and phone number fields. If you provide an invalid input, the application should throw a runtime exception. So, and here you may observe that I added a new annotation called display name. This annotation, as the name suggests, provides a custom readable name to your test. So instead of displaying the method name, which is sometimes not so readable, JUnit displays this custom name in the test results. So inside the first test method, we are verifying if the add contact method throws a runtime exception when the value of the first name field is null. For that, of course, we have to provide the first name as null, and we are verifying whether the runtime exception is thrown or not with the help of assertThrows method from the assertions class. This method takes the type of the exception we are expecting, so that in our case it is runtime exception.class, and as part of the second parameter we have to provide the supplier where we are calling the add contact method. So when I run the test again, you can see that all the 3 tests are executed successfully. If I open the other tests, you can see that I'm passing the value null for last name and as well as phone number fields. So now that we wrote a few tests, let's go to some theoretical aspects of JUnit and understand how the JUnit test lifecycle works. So each JUnit test, when it is executed, will create a new instance of the test class, and it follows different phases as part of the execution. Each phase is also represented with an annotation in JUnit 5. The first phase is before all phase, where the methods which are marked with this annotation will be executed before any of the test methods inside the test class. The second phase is the before each phase, where the methods marked with this annotation will be executed before each of the test methods inside the test class. And the third phase is the after each phase, where the method will be executed after each test method inside the test class. And finally, we have the after all phase, where some logic will be executed after all the test methods inside the class are executed. So the main use of these lifecycle phases is you may want to run some initialization tasks or some cleanup tasks when running the tests. Some general examples of this include setting up or creating test data inside the database at the start of the tests and cleaning them up after the test execution. So now let's go ahead and see how we can implement these methods inside our Contact Manager test class. The first one is the before all annotation. As I said before, the method marked with this annotation will be executed once for the entire test class. And usually this occurs before creating the instance of the test. For this reason, we have to mark the method as static, or else JUnit cannot execute this method. So inside this method, I'm going to print a message, which should print this message before all the tests are executed. And now if I run this test class, you should see that the message is printed before the tests are executed. So I just created a method and added the before all annotation, and this message is printed at the time of test execution. Now let's add the before each annotation. I'm going to create a method called as setup and add the before each annotation to this method. And inside this method, we are going to initialize the Contact Manager class. You can observe that inside all the test methods, we are creating the object for Contact Manager class. This is redundant, so we can move this logic inside the setup method. So I'm going to remove the Contact Manager instantiation part from all the tests. And I'm going to create a class variable Contact Manager and assign the variable to the Contact Manager object inside the setup method. Now you may think that we are using only one Contact Manager object for all the tests inside the class. This is not true. JUnit will create a new instance of the class for each method. So each test will work with its own copy of the test Contact Manager object. So now if we try to run the tests again, we can see that the tests are executed without any side effects. The same applies also for the after each and after all annotations. So I quickly created a couple more methods, and inside this method, we are just printing some messages. But if you're working with a more complex setup, usually you will clean up the test data created as part of the test inside either of these methods. As I mentioned before, JUnit instantiates the test for each test method, but we can also change this behavior so that it will create only one instance of the class by adding the test instance annotation to the top of the class. And to this annotation, we can provide the value lifecycle.perClass. By adding this annotation, JUnit instantiates the test class only once. In this case, we can remove the static keyword for the after all and before all methods. The next feature we are going to discuss is the conditional execution feature in JUnit. We can execute the test methods in our class based on a specific condition. For example, imagine if you developed a specific functionality on Linux machine for our Contact Manager application, which is after saving the contact, maybe we are performing some additional logic which is specific to the Linux operating system. Then we have to make sure that the test should only run when it's running on the Linux operating system, or else it's pointless to run the test. To enable this, JUnit provides us with annotations enabled on OS and disabled on OS. And to this annotations, we can pass on the operating system name as the annotation parameter. So I copied one of the existing test methods, and I'm going to add the enabled on OS annotation on top of the method, and I'm going to specify the value as Mac from the OS enum. And we can specify a message by providing an input to the disabled reason field. So let me copy the test again, and this time I'm going to add the disabled on OS annotation and specify the value as Windows because I'm using the Windows operating system. And if I try to run the test now, you should see that both these tests are disabled And actually, it's not clear which test is disabled, so I'm going to change the method name and display names. And if you run the test again, you can see that both these tests are disabled and we are able to differentiate which one is actually disabled. The next feature we are going to learn about is assumptions. These are similar to conditional executions annotations, but instead of executing the test conditionally, we are going to perform the assertions inside the test conditionally. That means if the assertion is not successful, then the test won't fail, but it will be aborted and won't be executed further. For example, you may have some unit tests which you want to run only on the developer machine but not on CI environment, or maybe some long running tests which you want to execute based on a condition. So in these cases, the test execution will simply be aborted if the criteria for the condition is not met. So let's see how to do this in practice. So I'm again copying the existing test and I'm going to rename it as should test contact creation on dev machine and also change the display name. And inside the test, before executing the actual test, I'm going to read the system property called env. This is the property which I have set inside the run configurations for the test. So inside IntelliJ, I'm going to edit the run configuration and add the property to the VM options. So you can see that I added a system property with prefix -d. So in the test, I'm going to read this property, and after reading this, I am passing it as a parameter to assertThrows method. So this is the method from the assumptions class, which takes in a Boolean parameter. There is also an assumeFalse method, which also takes a Boolean parameter. But in our case, we will use the assertThrows method to perform some assumption. And if you execute the test now, you should see that the test is passing. And now let's quickly change the property to another name. So instead of checking whether the property is dev, let's change it to test. And if you run the test again, now you can see the message assumption failed, but the test is not failing, it is just aborted. The next JUnit 5 feature we are going to learn about is the repeated tests. So in some situations, you may need to run a specific test case multiple times. Maybe because the functionality has a bit of randomness to it. Imagine you are generating a random number between a range maybe 1 to 10 or 1 to 50. And in those cases, you can say to JUnit to repeat the test execution for a certain number of times. We can do that by using the repeated test annotation. So this is just like a substitution for the test annotation, but the test method will be executed for multiple repetitions. So in our contact manager test, we are not dealing with any random functionality. So this is not a very good example for this use case, but we can still apply the repeated test annotation to check whether the test method is executed for multiple repetitions or not. So let's take the contact creation test again, and I'm going to rename it and add the repeated test annotation on top of the method. By adding this annotation, we can remove the test annotation, and to the repeated test annotation, we can pass in the value for how many times we want the test to be repeated. So I want this test to run for 5 times, so I'm going to pass in this value. And now if I run the test, you can see that you can see the custom name for the repeated test like repetition 1 of 5, 2 of 5, and so on. We can also provide a custom name for these repeating tests. So instead of just displaying repetition 1 of 5, we can make it more descriptive by passing the name field to the repeated test annotation. And here I'm going to pass the value for name as repeating contact test, and we want to know what is the count of the current repetition. So for that, we have the current repetition and total repetition values. If we specify these values inside the curly brackets, JUnit automatically fills in this value for these fields at runtime. So if we execute the test now, you can see the value repeating contact creation test 1 of 5, 2 of 5, and so on. So now let's learn about how to write parameterized tests in JUnit. Parameterized tests are similar to repeated tests, but the difference is you can run the test repeatedly by giving different set of inputs to our tests. Similar to repeated tests, we can replace the test annotation about the test method with the parameterized test annotation. After adding the annotation, we need a way to submit different set of inputs to the test method. We can do that with the help of some other annotations which we use together with the parameterized test annotation. So the first one is the value source annotation. By using this annotation, we can provide the input directly as a parameter value to the annotation. And the value source annotation support different types of literal values like strings, int, double, float, etc. So you can see the complete list of supported values on the screen. In our case, we need only random strings to test the contact creation, and we want to see if the validation for phone number field is working or not by providing different range of inputs. So remember that we are doing some specific validation for the phone number field. First, we are checking if the phone number is not null, and not empty. Then we check the length is exactly 10 characters long. We are making sure that the given string contain only numbers. And lastly, we are checking whether the phone number is starting with 0. So to test all these cases, usually you have to write multiple tests to verify each criteria. But using parameterized tests, you can provide different set of inputs and test them in only one test case. So back to the test class, I copied the contact creation test again and changed the name and the text inside the display name annotation. Let's add the parameterized test and value source annotation to this test method. And I'm going to provide a list of strings which contain some random numbers as the input. To be able to use these values inside our test, we need to provide a string variable as a parameter to the method. And JUnit then will automatically inject this value into the method while executing the test. And lastly, we have to make sure that instead of hard coding the value, I'm passing the phone number variable to the add contact method. And now if I run the test, you can see that the test is passing because I provided all the values which are valid. So I'm going to change one of the values here and provide an invalid value. So I'm going to add a plus symbol in front and run the test again. This time the test is failed because it's failing the validation that the phone number should be exactly 10 characters long. The next way to provide input for the parameterized tests is by using the method source annotation. Now you may have already observed that we are a bit limited to what input we can pass to the tests using the value source annotation. In the real world, the test data requirements are not so straightforward, and we may have to construct some complex objects as the test data and pass them to our tests. For that reason, we can use the method source annotation where we can refer a method inside the test class which is responsible to create the test data, and this data is then injected into our test. Let's see how to do that. Back inside the test class, I'm going to create another parameterized test, this time with method source annotation, and I'm going to create a method called phone number list, which is returning a list of phone numbers inside the test class. I'm going to just copy the method name and pass it as an argument to the method source annotation. And now if I run the test, JUnit will dynamically read the data returned from the method and will inject them into the test. So there is no need to change the test implementation, and let's go ahead and run the test. So you can see that all the tests are passing successfully. And if you're wondering how the previous test is passing again, I just changed the inputs to some valid inputs inside the value source annotation. So the next annotation we're going to use for the parameterized test is the CSV source annotation. Using this, we can declare the input data as CSV literals in our test. So if you're not aware of what is CSV, it's called as comma separated values. So as the name suggests, we are going to pass the input as a list of comma separated strings. So back to the test class, I'm going to create another test called as should test phone number format using CSV source and change the display name text. And I'm going to add the CSV source annotation, and to this annotation, I'm going to pass the valid list of phone numbers as comma separated strings. So it's a pretty straightforward, and if I run this test, you can see that the test passed successfully without any errors. And the last annotation we are going to talk about for the parameterized tests is the CSV file source annotation. This is very similar to CSV source annotation. The only difference is instead of referencing the list of comma separated strings directly inside the code, we are going to provide the reference of the CSV file directly to the CSV file source annotation. So this file is usually located inside the resources directory of the test folder in the Maven folder structure. So I'm going to create a file called as data.csv, and inside the file I'm going to just copy and paste the data we pass to the CSV source annotation. And if I go back to the test, I'm going to create another test method for this case, and inside the CSV file source annotation I'm going to assign the CSV file name to the resources field. Now let's run the test again, and they should be passing without any issues. The next JUnit feature we are going to learn is the nested tests. So as the name suggests, we can nest or group some tests inside our contact manager test class into an inner test class. So in our example, we have multiple test methods which can be grouped together. This may be some repeated tests or the parameterized tests because they belong to the same category. And if we organize these tests into their own classes, then the test class will look much more clean and well organized. So this is the main reason for using the nested class to make the test more organized. So I'm going to quickly create two classes: repeated nest test and parameterized nest test inside the contact manager test class. JUnit understands these are nested test classes by the nested annotation. So I'm going to add this annotation on top of both these classes. So the lifecycle of nested test class is a bit different than the normal test class. In the nested classes, we are allowed to only use the before each and after each annotations, but not before all and after all, because Java won't allow static members inside the inner classes. However, if you want to use the before all and after all annotations, You can change the instance lifecycle by adding the test instance annotation with lifecycle value as per class. Okay, now back to the test class, and I'm going to simply cut and paste the parameterized tests into the parameterized nested test class and the repeated test into the repeated nested test class. Apart from the change in the structure of the test, there is nothing changed in the code, so this change should not introduce any side effects for the test execution. So let's verify this behavior by running the tests again, and you can see the tests are passing without any errors. Now let's discuss the last JUnit annotation of this course, that is the disable test. You can use this annotation to disable some tests from executing in our test suite. So it's not generally encouraged to use this annotation until it's really necessary, because there's a chance that you will forget to remove the annotation after adding it and the test will be disabled forever, which is not so good. So to demonstrate this, I'm going to add this annotation to the first contact creation test we added. And if I run all the tests after that, you can see that the first test should create contact is disabled. So this is the end of this tutorial. Thank you very much for watching this, and I will see you in the next tutorial. Until then, happy coding techies.